Okay, welcome back to session 2 of heat exchanger design template presentation. I found the error. It seems it was not on the spreadsheet, and I will take you through what the spreadsheet does in order to identify the streams. The error was in the heat exchange simulation itself. If you compare now that I've run, if you go back to the previous video, you'll see that the heat exchanged was about 750. However, we already know from our manual calculation that our heat exchange is about 4,752. So if you check now, the simulation has corrected that, and it's giving a higher heat exchanged in order to get full condensation of your propane and butane. And the one more thing I had to change was for your product stream, instead of using ethane and propane, I've used propane and butane. This is quite important because your ethane and methane are similar. There's a comment that I made at the beginning of the first video, explaining that your methane would need subcooling in order for you to condense it. Same with ethane. So propane and butane are the better option. So I'm gonna go ahead and copy the material streams. So we'll refresh that and then copy to clipboard. We go back again to our template. Then we will go to your raw data. Then we just paste that over. Right. Again, this template is specifically made for use with DWC. If you're using another template, you're a consulting firm, you'd like the spreadsheet, you'd like access to this spreadsheet, it is important that you let me know which simulation you're using, or send me an example of your streams, right, of your property streams from the simulator you're using, so that I can customize the spreadsheet to your needs. Okay, so next we go to input data. Now you'll see that it makes more sense. So it's coming in at 333.15, coming out at 318. And then the same thing with the cooling water is coming in at 303.15. It's going out at 310.88. The heat exchanged is slightly different. And then I had pre-populated the information as your as you saw. The requirement was that you need an outer diameter of 20, the wall thickness of 3.2. That is coming from the value that were given, that the ID is 16.8, so that gives you an inner diameter of 3.2, right? A wall thickness of 3.2, sorry. And then lastly, this I would have to put in as well, 16.8, and then your tube length of 4.88 as described, right? The other thing, we are dealing with a condenser, so you can do a drop down. Either you choose liquid to liquid, gas to liquid, condenser, reboiler. The spreadsheet is configured to change your properties in order to match the service type that you have. And as I said, this particular spreadsheet, the product is meant to be in the tube side and the cooling liquid in the shell side. All right, so we proceed, and then now comes to choosing what you're working with. As I said, on the shell side, you're working with cooling water. There's a drop down that allows you to choose the different service types. And then on the tube side, we're working with light hydrocarbons. Again, drop down to allow you to choose that. Then you'll be able to. However, right, there is an option to either manually input. So if you have if you want to be more accurate and you have a more accurate accurate estimation of your fouling coefficients, you can then go manual, and it will require you to input the value yourself. For example, if we choose manual now, immediately you'll see your shell side changes to 3000, because we had it at 3000 for water. But then let's leave the tube side as it is, just for an example. But as you see, if you choose manual, it will allow you to choose yourself. And then in terms of the conductivity, you'll have to choose your material. As they said, as it was indicated in the problem statement, you are looking at Admiralty brass. So you choose Admiralty brass, and it should give you your it should give you your tube wall conductivity, which is 111 watts per meter. So next, we go to your shell bundle clearance. Again, this you can do automatically. And if you do it automatically, the spreadsheet will go search for the value and put it in for you. Otherwise, you can use correlations, or you can use charts where you then go manual to choose that. Right? Not gonna go into that. That's an easy part. Next, next you need to estimate your your initial overall coefficient. So what I'll then do is, if I change this value, let's start at 1500 for example, you will see it will auto iterate until it comes to a value that makes sense, right? But then the one thing I need to do in order to make sure that I'm correct is I need to update the number of tubes, right? So if you update the number of tubes, you'll see it has changed again to 439, because obviously your total area will change and your overall coefficient is dependent on area. So we will iterate again, but before you iterate, you can check if there's a need to iterate. If you go to your dashboard, you will see here there is there is a check for whether you have converged or not. Where is it? Right there. So if it says converged, it means you don't need to reiterate. But let's go back through the spreadsheet. Okay, so next to look at your number of tubes. Again, number of tubes, you have an option of doing it auto or doing it manual. Manual means you'll have to do the calculation, and you will have to come here and select. So the auto value is this one here, the 214. So it does the calculation here. As you can see, the last time the calculation was done was today at 12 o'clock. Right, so it is on auto. But if you want manual, you have to come here and change and say no. So which means now you'll have to do the calculation of the number of tubes yourself. Right, so the calculation of number of tubes, it's the formulas are in the spreadsheet. You can check, and depending on the client, there will be an option to have all the formulas written out, but they are already available on a explanation of the spreadsheet itself. Okay, so again, number of tubes, you can choose automatically or you can do manual. Number of tube passes, again, you can do auto. So the spreadsheet itself has been designed to do these calculations. So now, as you can see here, the problem statement itself did specify the number of tubes. So instead of using auto, I have gone for what? I have gone for manual. So I put in the 4.88, whereas everything else I left on auto. So it auto calculates everything. Next, the bundle diameter, again, you can choose auto or you can put it on manual. Manual will then, if you were given that the bundle diameter should be specifically, for example, this much as a ratio of the of the length. So that would be something that you'd now have to put in manually. It does everything from baffle cut. It auto selects the layout depending on the dimensions that you've given. For example, here it's chosen the triangular layout. You can put it to manual if you see that it is not optimizing as well. On the side here, these are your design notes. So for example, it will be telling you things like your area ratio, how is it it will be looking at your velocity targets. If you are within range, as you can see, it's normal. It will be looking at your recommended number of tubes, so here, for example, it's saying 2100. It says reduce NT to what? No, so it says it's normal, it's medium, right? So it's not too high, but you can still do something in order for you to get a better area. So these are all design these are all design recommendations that I've inputted into the spreadsheet to help you, especially as the student, to see if you're still within range, you're still within good design range. Same thing with the number of tubes. Again, here, your number of tube based on tube count. This is based on area. Then your number of tubes would be 2.12. It looks at your velocity as well, right? And then it looks at your, so if for example you want to go manual, you can take this value, rather 1554, and see how it changes your calculations. So what we can then do is we can go back here and say So obviously, again, if you want to change the number of tubes, you first have to come here and say do not update. So no, hold on. So you go no there, meaning that it's no longer on auto. Then you would come here and say I want to manually input my number of tubes, and we're gonna make it 1554, right? So that will change everything. And if you come here, you'll see nothing much have changed on here, but we can check. So if you want to check if your U estimate is correct, you just enter a value and the spreadsheet will automatically iterate. Okay, so then down here you'll have all your heat transfer calculations. So your mass velocities, your Reynolds numbers, your heat transfer coefficients, and then an important note, right? For condensation, this spreadsheet does not. What it does is if you put if you if if you allow it to calculate the value for the heat transfer coefficient for condensation, the heat transfer coefficient becomes too small, right, on the tube side for condensation. So what you need to do is, based on rules of thumb and recommendations from standard textbook, you need to use a fixed value. So if you run the spreadsheet using uh, liquid to liquid, for example, you will see that this value will calculate. However, on this one, it doesn't. It uses a fixed value of 1,000, right? Next, you look at your overall heat transfer coefficient, and it shows you here that you have converged. And again, it does a automatic. Also, it does your it does your it does your sorry about that. It does your pressure drop calculations. I just wanted to fix that. Okay. So these are the calculations themselves. You can double check, make sure that everything makes sense. You go through, but this is the heart of the spreadsheet. This is where you have all the hard fixed formulas, and then again now it gives you a summary. So this is your data sheet, not your this is your dashboard, right? This is where you now can get all the information on your heat exchanger. So it will give you the conditions on the tube side, the conditions on the shell side. It will give you the flow velocities, it will give you the dimensions of the spreadsheet, it will give you the design inputs that you put in. So this summarizes what you've done, tells you that you've converged, right? And then tells you your fouling. So when you go through it, it will summarize your pressure drop calculations on your cell side and on your tube side. It gives you your design note. So if, for example, it says to modify, you must go to the input data sheets, right? And then it gives you the references in terms of the information, or the models, the standards that this module was created on. And then here obviously it gives you your design warnings. So this is to tell you if you are within range or out of range. So here, for example, you have your tube side velocity. It tells you where the limit should be. You have your Reynolds number. It tells you that it should be greater than 2000. So this is your tube side. You've got your shell diameter less than 2000 for this particular design. Again, if your application requires bigger heat exchangers, you can always contact us, and the module will be modified to suit your needs. There it shows you a number of tubes, and then your L over D ratio. Again, it's within spec, it's okay. Shell your pressure drops, it checks that for you, and once that is confirmed, you are good to go. So, and then further design summaries, so you to go through. So this just look at conditions that you have and give you recommendations in terms of what else you can do in order to make your design more special. So let's go back to the one feature of this spreadsheet that allows you, right, to be able to copy and paste, right, your data without having to sort out the streams. So your raw data, as you can see, stream 1 here, let's go back to your, if you go back to your design assumptions, it does not necessarily mean that stream 1 and stream 2 follow through like that. As you can see here, your outlet on the tube side is sitting on stream 3. So otherwise, no, it's sitting on stream 4, for example. Otherwise, something would have gone off there. So what I've done is I've put in a I've put in a lookup, basically a lookup system, and for auto mapping the values. And what it does is it looks for your feet temperature and your cold temperature, your cold feet temperature, and then it matches everything else using the mass flow rate. You must remember your mass flow will be the same inlet and outlet for both streams, and then it does the match. So it is a rather nice spreadsheet to have. Again, it is not here to do your work. It is here to reference your work. You still need to do the calculations, you still need to do the designs, but this system is to give you a snapshot of how your heat exchanger is supposed to look like. So it's a good check, especially for your consulting firms who are doing heat exchanger designs. As an undergrad who just started working, this is a nice tool for you to be able to double check yourself before you submit anything to your employer. So give me a call, contact me, let's talk. I would love to share this spreadsheet with you. Again, tutoring sessions are $4.50 per hour. This spreadsheet is currently priced for students, right, at $6.50, right, once off. However, you will be required to do 1 hour session to a 1 hour tutoring session. So in total, the cost to you will come to about 1,100. However, for undergraduates and design engineers who are already working, the spreadsheet is priced at 5,500. I know it sounds steep, but it will really help you to start double checking your work and form a basis, right? In order to be able to start being able to produce your own models to help you with your work. All right, thank you very much. I look forward to meeting everyone who's going to engage with me. I hope this was a nice session for everyone who attended. Thank you very much.